that's strong in your local area. Maybe less so in coastal California, but creationism is always an issue in the Midwest, where I live and teach. And you want to keep creationism out of public education, you're going to need to be able to go up and say, in a non-technical way, why creationism really does not fit the bill for science. So having these diagnostic criteria is very useful for that sort of thing. And really, as I said, one of the things that skeptics really like to do is a sort of consumer protection activism at a certain deal. Skeptics care a lot about, say, stomping out alternative medicine and things like that, and largely because that's of our perception that this is fake and it's a fraud. You really are stealing people's money if you're trying to heal somebody's real problems by, I don't know, putting magnets in their souls or something like that. So we want a bullshit detector, and these diagnostic checklists are very useful if you're trying to build a bullshit detector. Now, this now has become, to a certain degree, absorbed very well by skeptics and skeptic organizations, and has become a sort of a stereotyped almost part of our skeptical rhetoric. And here's a recent example I pulled out. This is actually a fairly decent book. It's called Conspirituality: How New Age Conspiracy Theories Become a Health Threat. I learned a lot from this book about, it says a lot about the, say, yoga subculture in particular, which apparently has become a real vector for spreading all sorts of crazy ideas. In not just your classical fake science, but also mixed in with conspiracy theories and things like that. But there's one point in the book where the authors, again, fall back onto these diagnostic checklists and use a very sort of stereotyped skeptical rhetoric, and a quotation would be something like this: "The unfalsifiable claim of having intuitive access to the Akashic records is a standard trope among those adopting a professional mantle of oracular psychic or anyone who channels unquestionable higher truths from the great beyond." So we really fall into using this language of our diagnostic criteria, throwing around words like unfalsifiable and so forth. Now, okay, here's another source if you want to find out some sort of useful definition of science, some way of sorting the fake science from the real science. Well, one place we could go to might be a science textbooks, because after all, science education is supposed to help people to sort out the good stuff from the bad stuff. And interestingly enough, if you start looking around science textbooks, and since I teach at the university level, what's easiest for me to go is to knock on some doors of colleagues in different departments, and I ask to see things like the introductory textbooks they use in their first year science classes of various sorts. Now, if you look at, say, intro psychology textbooks, you'll find a lot in psychology textbooks about sorting out the difference between real and fake science. And one of the reasons is this: psychology is actually a very young science. Indeed, psychology has a very recent history of struggling with fake science, indeed elements in mainstream psychology itself. Say, for example, Freudian psychoanalysis and things like that. And so psychologists are very concerned about trying to, say, have some diagnostic checklists and criteria such as falsifiability. It's a way of legitimating psychology and saying, hey, we're a real science. We're not like 50 years ago where we did Freudian stuff and things like that. So then, if I talk to some of my biologist friends, I can look at their intro biology textbooks as well. Biologists don't do as much about separating real from fake science compared to, say, psychologists, because they're more mature science. Biology has been around for quite a long time. Nobody questions mainstream biologists' credentials as being real scientists. So in the intro biology textbooks that I've looked at, you'll find some descriptions of scientific method in the intro chapter, maybe a few pages, not necessarily a lot. But interestingly enough, they kind of understand the scientific method as very much as a kind of a statistical hypothesis testing kind of pattern. So the idea is that you have data, and then you feed the data into a statistical apparatus, and you crank through the statistical apparatus, you do your statistics, and out pop your results, and if they're significant, you publish them, and that's doing science. So it's very much following through a sort of a hypothesis testing procedure like that. Now here's an interesting thing. I teach physics. That's my background. And I have never seen an introductory physics textbooks where we spend any time at all describing the scientific method. There really is none of this. And in fact, by and large, physicists were not educated in the scientific method. Many of us really don't believe there's any such thing as a scientific method, as a sort of rules you have to follow to get things. We do not tend to, physics is among our sciences, among the natural sciences, the most mature of the sciences, and we tend to be a bit more skeptical about any recipe to be doing physics out there. Okay, I don't care if you come up with ideas by reading tea leaves. If it works, it works. That's a more general physics type of attitude. So you have a sort of ambiguous picture right now. If you look at the science textbooks, what you're going to get about the nature of science is going to really depend a lot on what kind of scientist you're talking to. Okay, then we might get another idea. We might say that, okay, there's a lot of people in our academies today, and there are people whose job it is to professionally study science itself as a practice, as a body of knowledge, as an institution, and so forth. And these people who study science are generally not in one particular department in a university. They're spread out between different disciplines. So there's a history of science, there's a philosophy of science, sociology of science, economics of science, you name it, of science is out there. But they tend to talk to each other, and the science studies people. There are some common elements in when you look at science studies, when they try and define what science is all about and tell us something that might be helpful in sorting out the real from the fake science. One thing is, science studies people tend to be very suspicious of checklists, of any type of thing, any list that you can sort of tick out the boxes and say this is real or fake. And in fact, science studies people will tend to say that there is no fixed method that defines science. There is no one thing called the scientific method. Different sciences, different areas of studies have different methods. They tend to be overlapping methods. We can talk to each other. But say, for example, physicists very rarely do double-blind studies. Because the kind of things we study are not out there that, if I'm looking at an electron is not going to fake something for me. But if you're doing a psychological study, if you're doing a medical study, yeah, you better have some double blinding. Because our methods are kind of tailored to what we're studying in the first place. And when you look at sort of the more current literature, and I put up a sort of a short book which is actually very good about this, recently came out a couple of years ago, people in the history and philosophy of science really don't talk about things like falsifiability and that type of elements of skeptical rhetoric anymore. This is by and large outdated mid-20th century philosophy of science. They really don't do this anymore. And one reason for that, one reason that criteria such as falsifiability have fallen out of fashion these days is it's way too rigid. For example, I mentioned that creationism can be a nuisance, particularly around where I live. And we do occasionally get people showing up, particularly around corners of campus, people who preach and say evolution is false, and they will say things like, essentially, Earth is 6,000 years or something like that. And for somebody who's a physicist, this is about as crazy a claim as you could make, the Earth is 6,000 years. We think it's false. We don't think it's unfalsifiable. So there's whatever is going wrong with creationism, it's not because it's unfalsifiable. It really is about as blatantly false as you could get if science has anything to say about this at all. Now, okay, if you point out some interesting features of creationist behavior, you will have a point. In that, if you talk to a creationist, if you try and ever argue with a creationist, I don't recommend it. I've done it when I was young often enough, and I'm not about to start doing this again. But often you will find that a creationist, if they're well studied, if they're really committed creationists, they will have replies to more scientific criticisms you can bring to claims such as the Earth is 6,000 years old. They will say something like, okay, well, you're bringing up things like radioactive dating, radiometric dating and things like that, but they will deny the validity of that. They will say something like, oh, well, Noah's flood happened, and because Noah's flood was such a global catastrophe and everything like that, all the clocks were reset back then, or something like that. In other words, they'll make up an excuse.
Right.
They'll pull up something out of their ass and say, okay, this is why all of your science really doesn't apply at all. And so definitely, if somebody is making up excuses like that, if you have shifting goalposts and things like that, that's very much a warning sign. It maybe is a good diagnostic criterion that you're looking at something that should worry you. But on the other hand, I also have to point out that this is the type of thing that legitimate scientists often do as well. For example, this is something that we were actually discussing around the dinner table last night, the issue of dark matter in astrophysics these days. And the basic idea over here is this. We have a lot of data that we have in astrophysics that seems to point out that if you try and account for our observations using everyday matter, the sort of stuff that's made out of protons, neutrons, and electrons and sort of things, it really does not account for a lot of the information that we have out there. And when this was sort of first discovered, one of the ways that astrophysicists proposed that we might be able to solve this problem would be there's a lot of dark matter out there, which is matter that interacts gravitationally but not electromagnetically with things. But we have no idea what this happens to be, and to this day, actually, we still don't have any idea what dark matter might be. In fact, I like to show this to my students once in a while, if they start getting too much of the impression that in physics we know about everything. I try and bring them down to earth by saying, this is our current estimation according to our best models of cosmology of what's out there. Notice that about 3/4 of what we think the energy in the universe is accounted for by dark energy, and most of the rest of it, and nearly another quarter, is dark matter. What we know about, which is pointed out by luminous matter or the non-luminous matter, which is our everyday things that we actually know what it is, that's just it. Dark matter and dark energy, we partially, you might say the name for that is because we're in the dark about what they actually are. We don't know what these things are. So the idea of trying to save a theoretical proposition by messing with the sort of boundary conditions that go into that theory is actually something that happens very, very often in the history of science. I mean, I'm just using dark matter as an example right now, but I could have used dozens of examples just from the history of physics alone. So there's nothing illegitimate about adjusting the situation, saying, oh, okay, if this was happening, then you can save the theory. As long as then you say, as you're aware that this is what you're doing, and you use that as a basis for further exploration of what's going on. And precisely that's what's happened in physics, actually. These days in astrophysics, almost every astrophysicist is very, very confident that there has to be some dark matter out there. And for very good reasons. We found independent lines of evidence that keep pointing us in that direction, even though we don't know what it is right now. As a starting point, it's not a bad idea necessarily. But now, let me sort of pause for a little bit right now. I've sort of introduced, again, this perennial question of how to separate real science from fake science, which is something that skeptics care a lot about. And then I've pointed to various different approaches to this problem. And the question that sort of confronts us right now is, okay, who are really the experts over here about the nature of science? Who are the experts that are going to help us to sort out the real from the fake? Because one of the things that very often, again, we're concerned about among skeptics is figuring out who has the appropriate technical expertise because we tend to trust it. But right now, I've thrown to you at least 3 different approaches to this question. One is skepticism from the trenches. People who have been dealing with, say, creationists in their local school board, people who have been dealing with fake psychics and things like that, have for a long time trusted in diagnostic criteria, rhetoric about the scientific method and falsifiability and so forth. Obviously, this is useful. And so there is a certain expertise over there that we need not to ignore. But then again, at the opposite extreme, I kind of showed you a little bit about science studies in academia. And I said that, okay, science studies people tend to mistrust this very idea of diagnostic checklists that can define science and non-science. So those experts seem to disagree with the skeptics right now. And interestingly enough, there is a history of friction between science studies and skeptics and scientists as well. Especially from the 1980s and 1990s, there were these science wars, and the science studies people actually flirted a lot with rather stupid, let's face it, postmodern ideas. And so what I want to do is I want to suggest that actually we can do a bit of both. We actually can take both the on-the-ground expertise of people in the trenches and people who academically study science as well. But what we need to do is to say that we want to check these checklists and the diagnostic criteria as starting points, as first approximations, that these are things that hint at problems, but on their own, they don't necessarily settle the case. So if somebody were to say, okay, dark matter is a bit of a problem in astrophysics right now, and it's a weak spot because we don't know what it is, and it's sort of made up in certain ways. Yes, pretty much every astrophysicist is going to admit that this is a problem, but yeah, here are these other reasons that we think that dark matter is real, and we're on the job, we're looking for it right now. So, what I would like to suggest then is that when we're trying to address the nature of science as skeptics, and indeed as scientists, what we might want to do is to adjust the metaphors we tend to rely on to describe science. Very often, we tend to rely on a metaphor of science as being based on scientific method. And the idea is something like this. The scientific method is something that's out there, kind of independent of how the world is. And it's something that is the foundation for our efforts. We feed data into the scientific method and we get results. And the method is what guarantees that our results make sense in the first place. So we tend to think of the scientific method as a recipe to obtain knowledge. This doesn't work. You run into unsolvable technical problems all over the place, and unless you ask me questions about it later, I'm not going to get into them. But by and large, I think the historians and philosophers of science have it right. There is no such thing as a scientific method that guarantees cognitive progress for us in some ways. Indeed, we should not think of scientific methods as something different than scientific results, because what methods are going to work best in helping us learn about how the world works depend on how the world works. These are not separate things from one another. There are better and worse ways to learn about the world, yes. If you consult a biologist, you'll learn a lot more about the world than a creationist. You'll learn a lot more if you talk to a physicist rather than somebody who learns tea leaves. But it's not because of some abstract method that guarantees our success independently of what we've actually done historically. And indeed, the checklist that we have been using in our common skeptical rhetoric, the rhetoric of falsifiability and so forth, we really have to accept that this is quite outdated. One illustration I like to use about that is this. One of the things that I was really interested as a kid was dinosaurs. I was a real dinosaur fanatic, and I never quite grew out of it. I still am a bit of a dinosaur fanatic. But it turned out that in high school I was good at math. And if you're good at math, you're going to be pointed towards physics rather than dinosaurs. But here's an illustration of dinosaurs I put up over there. And 50 years ago, when I was a little kid, this was the picture of dinosaurs that I would have in the dinosaur books that I really loved.
Right.
Yeah. But of course, anybody who's actually followed dinosaurs in the 50 years since is going to know that this picture is very much outdated in the way that these dinosaurs actually look. And if you look at a more modern illustration of, say, a theropod dinosaur, you're going to see something like this. The stance is different, the way it holds its tail is different, it's covered with feathers, it's much more bird-like and everything like that. Now, these two pictures are not radically different. The 50 years ago picture I had in my kids' books was not some sort of radical mistake. But it is outdated. And we have learned a lot more about dinosaurs since then, and we have more modern pictures of what's happening with dinosaurs. And with any luck, 50 years later, we'd have an even better picture of dinosaurs, and it's also going to be different. So since a lot of our skeptical rhetoric today relies on sort of mid-20th century philosophy of science, it's kind of time to update ourselves. We need better metaphors. Instead of talking about things based on a method that is separate from scientific results, we're going to be much better off adopting a much more up-to-date metaphor of a network of mutual support, where you do not have methods and results that are separate from one another, and the way that you actually justify the results is actually very similar to the way that you justify methods as being a good way of learning about the world. And as a bonus, we end up with a picture of science that is much more sort of this-worldly. There's always a tendency, if you try and say the scientific method is something similar, it's something separate, it tends to seem like something that's come down from the sky. It's almost sort of otherworldly. But what we actually know about science as a human practice makes it very unmagical. This world is just people trying to figure out what's going on. And really, to a large degree in science, we are making it up as we go along. We don't have guarantees, we don't have certainty, but we still have a very reliable way of actually learning about what's going on. We should be focusing more on science as a way of institutionalized criticism of ideas and learning about things. And that should shift our emphasis. What this also means that if you have fake science, this is largely going to be a failure of institutions more than logic. And let me give an example that I hope will bring this out a little bit more. To come back to creationism again. For those of us in this room, creationism is probably a very, very obvious bullshit idea. But if you look at the institutions that drive creationism, say for example, the Institute for Creation Research, or the Discovery Institute, who's pushing the intelligent design version of creationism and so forth, these institutions are very different than scientific institutions in many respects. These institutions are really what I call apologetic factories. They're out there to manufacture reasons by hook or by crook for their underlying, very often religious ideologies. They're part of, and they're not isolated when you have to consider institutions in their context. They are part of a very much of a right-wing populist environment today. This is important. And because of that, creationism tends to be not isolated, tends to be linked to other crazy ideas. So creationists will very often also be involved in resisting vaccines. Creationists are much more likely than anybody else to be climate denialists and everything like that. And this has to do with the institutional features and the overall social context in which they operate in. These are the kind of things that I think skeptics should be paying more attention to. And other examples, one of the things that I've been able to observe over the last few decades and be able to study is the Islamic version of creationism, which is actually even stronger than the Protestant version of creationism we are so familiar with in the United States. And what makes it interesting is that the Islamic version of creationism obviously operates with different institutions in a different social context, and sometimes it can be very much stronger than the US version of creationism we are more familiar with. In some places in the Muslim world, creationism finds direct state support. It is part of their education system. It can be rather entrenched ideology that way. And so we can sort of compare these different institutions, how they operate in a more global context, and I think it gives us a much better understanding of something like creationism rather than throwing things like rhetoric like falsifiability against the wall. This is a poster that I like. This is in Turkish, and this is to give you an idea about how creationism can be very different in different parts of the world. This is the 7th International Conference on Creation in the Light of Science. Wow. This is from 2023. They hold one every year pretty much right now in Turkey. This is in one of the provincial Turkish universities. And these are actually big conferences that attract academics from all over Turkey and a significant minority from other Muslim countries as well. And so there will be people, biologists, engineers, theologians, and so forth, for 3 days come up in a university and basically tell everybody why scientifically evolution is wrong and why the Quran is something that we need to fall back on and everything like that. So This to me is a more interesting, perhaps fruitful way of approaching questions like what is real and what is fake science. So yes, so therefore what really is wrong with creationism? Where's the weirdness over here when you compare creationism with real science then? Well, these, as I said, the institutions of creationism largely operate as apologetics factories. And apologetics is necessary to defend beliefs that happen to be a very bad fit with the general body of knowledge that we have in science. We do not have the idea of mutual support with things, with other areas of science and creationism. Creationism involves a massive and seriously massive disruption of science across the board. Because special creation is not just a crazy idea because it happens to violate some very important biological ideas. It's equally crazy chemistry, it's equally crazy physics and everything like that. So mutual support goes out the window, it becomes very, very disruptive. So creationism in that way is perhaps institutionalized bad science. And particularly because they tend to put ideology before investigation. But here's the thing. If you start concentrating on institutions and start asking the question of how should we organize our institutions in order to best learn about the world, that also means that when we're looking at science, we should be doing exactly the same thing, like the science studies people tell us to do. We should be looking at how science as an institution is structured, and we will find that sometimes this does a very good job, and sometimes, well, maybe not quite so much. And pretty much everybody who works in science knows that the institutions that we have today for doing science are flawed, because we spend half of our time complaining about what the administration is up to and things like that. It's not perfect. Now, we know that science can be pretty trustworthy, but very often the trust that we place in science is based on the assumption that scientists can operate independently and have the freedom to investigate questions because of their intellectual interests. Very often this is true. By and large, in my experience in a basic science like physics, I have found this to be true, but there are exceptions, and particularly as you go to the more applied science fields, things get a lot more complicated. Even in physics, you always have in the background the idea that physics has to be funded, and the money that comes to physics is always going to be tied to military and commercial interests at some level. And we would have to be fairly naive to expect that this is going to be completely independent, has no effect really on the practice of science. It does some. By and large, it's not a huge deal, I don't think, but it's something that we have to keep in mind. And also, while we're talking about criticizing possibly mainstream scientific institutions, we also have to keep in mind that things are not perfect, but they're also sometimes getting worse in some respects as well. One of the things that worries me about the way we do things in universities today is there's a tendency to press science in the service of what I might call an intellectual property mill. Because people are now, this is a situation, at least in physics, I can speak to this most closely, but people's careers, how their positions in physics right now depends largely on the amount of grant money you can bring in. Mm-hmm. And that affects things. And when you go away from more established, mature fields like physics, when you start going into more applied and less mature sciences, you start getting more serious problems. You may have heard of the replication crisis in many, especially statistics-dependent fields, that has been with us for over a decade right now. And that's certainly made worse by the whole institutional context where people have to operate in. Mm-hmm. So the idea of cranking through the statistical machinery and coming up with a result, that's not really how science operates. And if we tend to have that image of science, we're going to kind of miss some of these institutional problems that we actually have with science. I'll actually come to questions in just a moment.
I have a quick clarification.
Go ahead.
Can you explain what you mean by applied fields?
Well, applied fields might be sometimes, well, if you look at fields that have especially run into problems with the replication crisis, you're looking at things like, say, food science. Or if you're talking about medical science rather than biology, engineering rather than physics, fields where some direct application or technology production is in the forefront, rather than asking questions about, okay, how does this thing work? It's obviously, this is a very much a gray area in between. There's no sharp separation between basic and applied science, but practically everybody knows there's a bit of a difference. Okay, so let me start wrapping up then. What do I really want skeptics to do in a situation like this? What I would first and foremost like to see us do is, I want us to ease off on jargon and slogans like, this is unfalsifiable. I really think not only is this outdated, it's not really even helping us all that much. And if somebody comes up to you saying that they claim to read Akashic records, if you tell them that they're making shit up, I think that's a perfectly legitimate way to challenge them. And you're probably 100% correct as well. And also, and since I've sort of suggested that we have the institutional and social context in our minds a little bit more, this means sometimes skeptics, what we do, there can be a danger of defending institutions associated with, say, for example, our social class and things like that, because we tend to represent educated professionals and so forth. But we want to be careful that that's not just what we're doing. We want to be trying to defend accuracy in our description of the world. That's really what science is trying to be aiming for. We're not just trying to defend our social position as educated professionals. That in today's in today's political environment, I think that is a real danger that we should be aware of. So, like many an academic, I'm kind of going to have to conclude that things are complicated. Sometimes, as skeptics, we can fall into the pattern of defending a kind of a heroic image of science, drawn in these sort of classical pictures of this sort of profile and chin and everything like that. And I'd like to, I grew up sort of this way, and I'd like to have this as well. I'd like to have these clear lines between the real and the fake. I'd like to be able to promise progress with a capital P if we trust and reason with a capital R and so forth. And I certainly do not want to aid creationists or alternative medicine people. Science really is our best effort at understanding the world, and usually we do a very good job of it. But this heroic image is, we have to admit, it's not very accurate. Now, we do not want to replace it with an image where we're all mad scientists.
Aww.
Where we're just crazy people just screwing around. A more accurate image is just going to be that scientists are people sort of trying to figure things out. And okay, scientists may have to spend more time reading physics books and things like that than most people, but by and large, there's no sharp separation over there. Okay, so again, thanks for listening. I try and develop these ideas a bit more in the book I've brought a stack of. If you want to get hold of a copy, talk to me. A lot of these, actually, I have related articles that I keep posting on that website. If you want to check those out, that might be helpful. As I said, I've been working on more of the history and philosophy of science for the last 20 years, so this is kind of a summary of some of the things that I think I've learned during this time. And I don't know how much time I have left. That's up to Susan.
You can take a couple questions.
Okay, so
and then you're also here.
Yes,
so
you'll have questions, because I find very often that in these talks, the part that I enjoy sometimes the most is the questions, because you guys tend to have really good questions for me.
Yeah, do you have a couple questions for him? And keep in mind, he will be here, so we can talk to him further if it's a longer question. Answer.
Can you give us a couple keywords that we can Google to learn more about this?
Okay, if you want to start with a bit of the sort of history of the philosophy of science, which might be helpful, you can start with Popper and falsifiability. But keep in mind that what you're going to be encountering there, say if you pick up the Wikipedia article, it's probably going to start talking about falsifiability as it was developed in the 1930s and things like that. So you'll be starting with a sort of a century-old philosophy of science, which was okay back in the day. What happened then was that a couple of decades later, especially psychologists picked up on this falsifiability rhetoric, and they use it for their own purposes. And it's sort of established itself as a kind of a default philosophy of science among most scientists. But scientists' job is to do science, not philosophy of science. We're not exactly necessarily very good at it always. So you probably want to start with the history of things. Is that really answering your question, or I'm sort of?
It's a good question too.
I was thinking Sam Weinberg's idea of lateral reading. So in other words, I have a weak scientific background myself. My family's creationist.
Oh,
So,
okay.
I've made some progress, but I'm not a physicist. So
Sure.
Lateral reading says, instead of engaging directly with questionable content, you go outside and see if it's controversial.
Yes. That probably is very good advice, but I would be answering that question not from my own direct experience, but because of stuff that I've read that suggests that's a good way of approaching things. You don't confront people head on with this type of thing. The thing is, if you're looking at advice for ways to talk to people who are creationists, or people who are, say, vaccine deniers or things like that.
But where the rubber meets the road now, there's all these new dietary recommendations.
Right. Now,
it's our future health. It's on.
Here's the thing. I'm the wrong person to talk to, and the reason for that is I have had the luxury throughout my life of dealing with people primarily in the context of the classroom, and in the classroom, things are set up such that I'm the authority. I run the show. The student knows this, and if the student says something that's wrong, I know how to deal with them in the context of that. But if you take someone like me with no experience in dealing with, say, a public meeting where somebody opposed to vaccines is going to come up and say something, I'm going to be a fish out of water. So I don't want to create the impression that I know how to deal with these things, because I don't. And precisely because I spent my life in a very artificial environment of a university classroom. So I don't know, is my most honest answer to you. Sorry.
Great answer.
Yeah.
Go ahead.
If you want a recommendation, I can recommend the book. I grew up in physics. I studied physics very much in standard. The book that revolutionized my thinking about the nature of science and how it evolves is Thomas Kuhn's book, The Structure of Scientific Revolutions. I found it completely undermined my traditional beliefs about the nature of science and started me on a different way of looking at the world. So that's a book I recommend to people.
Yeah.
I know my book is a spin-off of that, if you like. It builds on that idea, on the idea generated by Kuhn.
Kuhn is good. However, Kuhn is notoriously open to interpretation and a lot of debate.
Yes.
And Kuhn is 60s stuff. That's pretty outdated today as well. I think if you want to start out with a sort of a more current view of the history of science that has to do with the separation of real and fake science, this book is a good one. Particularly because this is actually a fairly short book. It's about 60 pages or so. It's in a booklet series that Cambridge Elements, and Cambridge Elements, when they do things, when they commission somebody to write a book like this, they say, you have at max 30,000 words. This is going to be a short booklet. You have to be short and to the point, and you're not going to drown your reader in jargon and all the academic nonsense. You're going to have to try and do a good job of presenting things quickly and shortly and to the point. I've written one of these things as well, so I know how it works. It really disciplined me reasonably well. And this book is actually a pretty good book.
I know that Kuhn is old, but I felt embarrassed to recommend my own book.
Yeah, fair enough.
Don't be embarrassed. Come on.
Recommend your own book.
Which is
gives me an excuse to recommend my own.
Yeah, 3 years old.
Go ahead.
I wanted to ask about the issue you raised with replicability of either applied or non-applied science versus mature or non-mature sciences, which you talked about earlier. And I ask this because I look at engineering and I don't really see a replicability problem when I see engineering.
No, not as much. Because
and that's as applied as you get.
Yes. It's not an applied versus non-applied direction, because engineering also tends to deal with systems that are fairly simple. So yes, it's fairly, but when you're talking about, say, something like social psychology or something like that, they operate under very difficult conditions compared to a physicist, in that the systems they're dealing with from a physicist point of view, is nightmarishly complex. And they don't have a nice, good, solid theoretical background to constrain things too much. About all you can do in such fields is to try and get data and do some statistics and try and figure out something that's going on. These are fields that are very theoretically undeveloped. Engineering is not so, because at least engineering has the whole theoretical apparatus of physics as a backstop. So engineers can always rely on that. So, yeah.
Thank you.
Go ahead.
So, one comment. You say physicists don't double blind. And in the classic double blind
Mhm.
medical
Sure.
test, physicists don't double blind. But there is a really interesting, at least to me, fairly recent development
Mhm.
in physics, astrophysics, particle physics. There's from the history of science, if you look at the measurements of things, so if you look at a graph
Mhm.
of the speed of light, what was the accepted value of the speed of light
Mhm.
and the size of the error bars?
Right.
It moved in jumps because people would do an analysis, they
Mhm.
figure out a new way to evaluate the speed of light. They thought about all of the things that could affect their measurements
Mhm.
and stopped when they got an answer that agreed with the previous number.
Yeah.
So they weren't cheating.
Yeah, yeah.
They weren't doing it wrong, except they were,
Right.
and they didn't know.
Yeah, yeah. I mean,
So what's happening now is they will leave a well-understood systematic factor
Mhm.
out, do all the analysis,
right.
think of everything they can, without knowing whether or not the answer they're getting is
Mhm.
even in the ballpark.
Yep.
And then another group will say, all right, here's the systematics that you left out.
Mhm.
This is your answer.
Right.
So it's not
Yeah.
double blind, except
Right.
that it sort of is.
In some ways, yes.
Yeah.
And in fact, again, if you look at the history of physics, some of the very interesting examples that are very similar to that, actually, some of the best examples comes to us from about mid-20th century particle physics.
Yeah.
And you look at some of their graphs, and yes, you seem to see a sort of a convergence on something that's going on, and then, whoops, something else happens, they converge on something else entirely. So these are actually some of the classic illustrations of our critical dependence on strong interactions between theory and experiment.
Yeah.
So if you do not have good experimental constraints, theoretical physicists can, the way T.D. Lee put it, would tend to drift. And you can have some theoretical consensus, but not necessarily having anything to do with reality. Some critics of string theory actually accuse it of it in being in such a situation right now. But there's the other way around too. You can have experimentalists seemingly agree with each other about the facts of the matter, but if they don't have theoretical guidance, they can actually reach a false consensus very easily, and historically this shows up very often too.
It's not really double blind.
No, yeah.
But at some level, it feels.
Yeah, I mean,
It's appealing to the same flaws in our.
yes,
psychology.
definitely, right.
Yeah.
All right. Okay, sounds great. So we're gonna be able to thank you so much, Tanner.
Okay.
That was amazing.